Welcome back. This is Objective 2, the greatest common factor. Last section, we talked about factors of integers. With this unit, we are focusing on polynomial factors. Pause the video now to look up the word polynomial. What did you find? Maybe you saw, but polynomials come in all shapes and sizes. A monomial is a single-term polynomial, such as 2x, x cubed, or 4x squared. Again, a monomial is a single term coming from the root mono, such as 2x, x cubed, or 4x squared. Each of these are a single term, and there aren't any addition or subtraction signs connecting it to multiple terms. Following the same suit, a binomial, coming from the root bi, I'm just going to make this a little bigger, is a polynomial of two terms, such as 2x plus 1, x cubed minus x squared, or perhaps 3x to the fourth minus 2x, and many more. Following the same pattern, we also talk a lot about trinomials, which are most popular in factoring. Tri, if you can't guess, is a three-term polynomial, most commonly looked at as x squared plus x plus 1. Another trinomial might be 3x to the fourth minus 2x cubed plus 1. Our first factoring technique is to factor out the greatest common factor. That is our goal for the day. If you don't remember what a GCF is, which stands for your greatest common factor, pause the video again and refresh your memory. So we can look at the greatest common factor between any two numbers. For instance, the GCF between 16 and 4 would be 4. The greatest common factor between 16 and 12 would be 4. The greatest common factor between 13 and 3 happens to be 1. We could do many more examples of this, but instead we're going to jump into the GCF of binomials. You can't find a GCF of a monomial because there's only one term, and so it would be the term itself. But if we take an example such as 4x squared plus 2x, we can factor out the GCF. Here, we look at the coefficients first. What's the GCF between 4 and 2? That would be 2. We can also look at our variable. Here I have an x squared and an x. So the GCF of x squared and x would be a single x. What I have remaining is if I divide 4x squared by 2x, I have 2x left over. If I divide 2x by 2x, I have 1 left over. You want to make sure that you write down this plus 1, because if you just left it as 2x times 2x, you would get 4x squared, not 4x squared plus 2x. So we don't want to lose that last factor. Another example might be 4x squared plus 8x plus 2. Is there any number that goes into each of our coefficients? Good. The GCF is 2. Then I have x squared plus 4x plus 1. Is there another GCF between these numbers? No, so we would be done. I'm going to do one more example with you. Let's come up with a number, maybe 6x squared plus 12x cubed plus, we'll do 30x. Here we can find what is the GCF of 6, 12, and 30. It's going to be a 6. That's going to give me x squared plus 2x cubed plus 5x remaining. Is there a GCF of this trinomial? Good, we can pull out an x. So I'm going to get 6x times x plus 2x squared plus 5. And that so far is factoring by finding the GCF. Go ahead and try the practice problems in the document attached. Just remember, anytime you go to factor a polynomial, you will want to check to see if you can factor out a GCF first. So GCF, you should think first. We're going to use this throughout the rest of the chapter. Good luck.